Here we have a problem on simplifying numerical expression. Okay, let's consider the numerical expression over here, and in which I consider the first part, that is 2 over 3 whole cube. So whenever we have an exponent for a fraction, the exponent can be taken separately for numerator and separately for denominator. So in that case, I'll be getting 2 to the third power over 3 to the third power. And here for the second fraction, we have a negative exponent. So whenever we have a negative exponent for some stuff, the negative exponent can be changed to positive, and for this base, we have to take reciprocal. So when I take reciprocal of 2 over 3, it will become 3 over 2, and we have to change the negative exponent, that is negative 2 to positive 2. And here we have the base 1 half, and we have the first exponent 2, and for this complete stuff, we have the exponent negative 2. So to simplify this one, we can use the power of a power rule in exponent. What is the power of a power rule? So let's consider a to the mth power. So here the base is a, and we have exponent m for the base a. And for the complete stuff, let's consider the exponent n. So whenever we have two exponents like this, what we can do is we can multiply the two exponents m and n. So this is a power of a power rule. The same stuff we have over here. We have the base and we have exponent 2, and for this complete stuff we have again we have an exponent negative 2. So what can we do with the two exponents? We can multiply them. So when I multiply these two exponents, 2 and negative 2, it will become negative 4. So I'm getting 1 over 2 to the power of negative 4 times 1 over. Okay, here we have the denominator 24, but when I look at the stuff in this expression, we have 2, 3, 2, 3, 2, 3. So at everywhere we have the prime numbers 2 and 3. So better we can write 24 in terms of the product of the two prime numbers 2 and 3. So how can we write this one? So for that we have to resolve 24 into the prime factors 2 and 3. So 24 can be written as 2 times 2 times 2 times 3. So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24. And this 2 times 2 times 2 can be written as 2 to the third power times 3. So 24 can be written as 2 to the third power times 3. So here instead of 24, I can write 2 to the third power times 3. Everything has to be divided by. Here for this fraction 2 over 3, we have the exponent negative 5. So we can change this exponent negative 5 to positive 5, and we have to take reciprocal for this 2 over 3. In that case, I'm getting 3 over 2. The reciprocal of 2 over 3 is 3 over 2 to the positive fifth power times here the same thing again. We have negative exponent. We can change this negative 12 to positive 12, and we have to take reciprocal for this 3 over 2. When I take reciprocal for 3 over 2, it will become 2 over 3 to the 12th power. Okay, let's do further simplification. So we have 2 cube over 3 cube times here we have exponent 2 for this fraction 3 over 2. So this exponent can be taken separately for the numerator and denominator. So when I do so, I'll be getting 3 square over 2 square times. So here we have a negative exponent. So what we can do is we can change this negative exponent, that is negative 4 to positive 4. In that case, I have to take reciprocal of this 1 over 2, that is 2. So then I'm getting 2 to the fourth power. So times 1 over 2 cube times 3. Everything has to be divided by. So here we have exponent 5 for this fraction. So this exponent 5 can be taken separately for the numerator and denominator times. So the same thing we have for this one, that is 2 to the 12th power over 3 to the 12th power. Okay, in my next step, what I'm going to do is I'm going to change this complete division as multiplication. When I change this division as multiplication, I have to take reciprocal for these two fractions. Okay, let me do this. So for that, first I have to write the expression we have in numerator as it is, that is 2 to the third power over 3 to the third power times 3 square over 2 square times 2 to the fourth power times 1 over 2 to the third power times 3. So now I change this division as multiplication. The reciprocal of this one is 2 to the fifth power over 3 to the fifth power. So reciprocal means you have to flip the numerator and denominator times the reciprocal of this one is 3 to the 12th power over 2 to the 12th power. Okay, now so what we can do is like here we can combine the terms at the same base numerator. So whenever we multiply terms at the same base, what we have to do is we have to take the base ones and add the exponents. That is a product rule of exponents. Okay, let me write the product rule over here. That is a to the power m times a to the power n. Here I multiply two terms at the same base. What we can do is we can write the base once, and we have to add the exponents, that is m positive n. So here we can apply this product rule over numerator. So here this one, and this one, these three terms are the same base 2. So we can write the base once, that is 2, and we have to add the exponents 3, 4, and 5. When I do so, I'll be getting 3 positive, 4 positive, 5. Okay, here. So, and then we have 3 square, 3 to the 12th power. So these two terms are the same base. So what we can do is we can take the base ones and we can add the exponents. And we don't have to consider this one because when the entire stuff over here is multiplied by 1, again we'll be getting the same answer. So we can simply ignore this one. Okay, in denominator also we have to do the same thing. So this one, and this one. These three terms are having the same base 2. So we can take the base ones and we have to add the exponents. So when I do so, I'm getting 2 positive, 3 positive, 12. So the same thing we have to do for these three terms, that is 3 cube. Here we have 3, here we have 3 to the 5th power. And for this particular 3, we don't have any exponent, so we have to assume there is exponent 1. So for these three terms, we can take the base ones, that is 3, and add the exponents 3, positive 1, positive 5. Okay, now let's do further simplification. That is 2 to the power. So when I add these exponents, I'm getting 3 positive 4 is 7, 7 positive 5 is 12, and times 3 to the power 14 over. So here we have 2. When I simplify, when I add the numbers 2, 3, and 12, I'm getting 17 times 3 to the power. So when I add 3, 1, and 5, I'm getting 9. Okay, now so here. So the two terms are in division with the same base. Here also we have the two terms are in division with the same base. So whenever we have two terms are in division with the same base, what we can do is we can take the same base ones and we have to subtract the exponents. That is a coefficient rule of exponent. Let me write it over here. So I am dividing a to the mth power by a to the nth power. So here we divide two terms with the same base. What we can do is we can take the base ones a and we have to subtract the exponents. Then we'll be getting m negative n. So now let's apply this coefficient over here. So then I'm getting 2 to the power. So here for these two terms, I'm just taking the base ones 2 and subtract the exponents 12, negative 17. And the same thing for this one, I'm taking the base 3 ones and subtract the exponents 14, negative 9. So here 2 to the power, when I simplify this one, I'm getting 2 to the negative 5th power times 3 to the power. When I simplify this one, I'm getting 3 to the 5th power. Okay, here this 2 is having the negative exponent. So what we can do is better whenever we have negative exponent for a number. So if I move this number, if I move this term to denominator, so this negative exponent will become positive. So we have 3 to the 5th power over 2 to the 5th power. Since I move this term to denominator, this negative exponent becomes positive. So the value of 3 to the 5th power, to get the value of 3 to the 5th power, we have to multiply 3 by itself for 5 times. When I do so, I'm getting 243. And to get the value of 2 to the 5th power, I have to multiply 2 by itself for 5 times. When I do so, I'm getting 32. So the simplification of the given numerical expression is 243 over 32. So we find 243 over 32 in option D. So the correct answer choice for this one is option D.